Good evening. So tonight we're going to work on tract again, and the goal for tonight will be to implement one more operator. It has been requested by my friend Tom Solberg, who is a contributor to tract. I did a lot of work on the support of Intel kernels for AVX 512, and I mean, there is a lot of activity in this space these days, which is good because I'm not focusing a lot on AVX 512. Naturally, my interest is more on the ARM architecture, so it's good that some people find the time to work on the big Intel chips. Let me just put my second screen to the right place. Yeah. And the operator that we want today is TopK. So there is this website which does something nice with the ONNX specification, but I kind of like, I mean, it's more like I'm used to it more than like it because it's really basic. And so TopK is right here. And so this operator takes a tensor, and it has two inputs. So the first is a tensor with a relatively complicated shape. The second input is a 1D tensor containing a single positive value. That's bad spec if you ask me, but it's not the point here. Corresponding to the number of top elements to retrieve, and retrieve the top K, so that's where K comes from. It comes from second input, largest or smallest elements, so I guess depending on this guy, which is an attribute of our tensor, along a specified axis given, so the axis I guess is this guy, given an input tensor of shape A1, A2, AN, R, and integer argument K returns two outputs. So we have two outputs this time. The first output is a tensor of shape blah 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 blah, axis -1. So yeah, we are skipping axis because it's defined here, and so the new dimension on this axis will be K because we return K rows or K planes or whatever, which contains the value of the top K element alongside the specified axis, index tensor, which has the same shape, which contains the indices of the top K element, original indices from the input tensor. So that's, you get kind of extended max plus argmax. So this will be its position, and this will be the values. If largest is 1 default value, then the K largest elements are returned. So if it's 0, it will be the smallest. If it's sorted, then the resulting K element will be sorted. If sorted is 0, order of returned values and indices are undefined. So that's not super nice. Why is it not super nice? Because if the order is undefined, it means that the test for the non-sorted case will be unusable, because the test will not, the output will not be defined enough. We can have several orders for the outputs. So this is going to be a bit complicated unless we don't have test for the unsorted case, which so sorted is default is 1. So this one will be sorted, this one will be sorted, and this one will be sorted. So they never test the unsorted case. And So as it is not defined, I'm free to do whatever I want. Whether I'm doing the same thing, so I'm sorting all the time, which is not super efficient because we will sort the table, we will sort the entire table, or else I'm doing a select. So select is a simplification of the sort algorithm. So for instance, for quick sort, we have quick select that will just give me exactly this, so the TopK elements, without having to sort the entire table. But I think I'm going to sort because I don't think this operator will be used in super critical code path. So I'm going to do sort all the time. Okay, and so that's one less case to manage. And yeah, when it becomes a problem to sort all the time, we can address it later, but at least we will fit the bill fixed by specification. Okay, so there are a few other difficulties with this operator. One is the size of the output depends on the value of an input, this k. So if we don't know the value for the second input very early, we'll have a problem because there is a rule in tract which say that given the shapes of an input, we have to be able to predict the shape of the output for each operator. So that's going to be a problem, but we have a workaround, so we'll see into that. I mean, it's not a workaround, more like a way to make exception to these kind of golden rule about the shape and shape prediction. So let's try and start to write some code. ONNX TopK. Okay, so first let's see if our tests are there in the ONNX test suite. So ONNX comes with many tests, not covering everything, but for this TopK we have 3 tests that we can use. And so the tests are written in Python on ONNX side, and there is a huge lot of plumbing in tract that use this test that makes a Rust test out of this Python test. So if I do cargo test TopK, and I'm adding ignored because these tests are tagged as ignorable because they're not working. Just checking the name, so it's top_k. Okay, start again. I'm gonna keep TopK, I think. Like it better. So top_k, top_k negative axis, and top_k smallest. Okay. All right, so we have our 3 tests, which are run in 3 modes by tract. And for now, we're going to focus on this guy. So the point of just focusing on the first one is, so we have to add the exact, because this spec matches 3 of them. Here we go. So we have the first one. And so the first one in plain mode is basically we just need to make it work. Or at least try. So ONNX. Where am I going to put it? I think it's going to erase. Yep. Feels like it feels right in array. So ONNX src ops mode. We're going to add TopK. Oops. Yes. hopefully it will not break everything, or else I will be in big trouble. So TopK, and we will register TopK. Okay. TopKey, topkey.rs. CRC ops array. So I'm getting another operator to know what I need to do because I'm lazy. All right, let's go this. So first we need the function that will be called by the framework at initialization, and that actually this is wrong. This is not what I was describing, so I will need another example, array, but I'm going to explain. Sure, I need a register function, register something. So if I'm looking, if I look here, where did I add the TopK thing? I'm lost. Okay. So I change SRC ops mode, so that this was wrong. Let's forget about that and we'll do it again. So I'm going to add it in array, so it's array mode that I need to change. I will add mode TopK, and so I have two ways to add, and here I'm skipping the, so I'm skipping the registering function because basically I have one operator to register per submodule. So let's call TopK. So here I need to, this must match the ONNX spec, so that should be TopK, just like that. And we are going to call a function in TopK, and function will be called TopK. So this function will be responsible for parsing the ONNX protobuf file. I mean, not the protobuf, but the already parsed protobuf. Analyze it and build the tract operator that we will use later on. All right, so RCRC ops array topk.rs. Okay, I already have this one. So this is a function that parses the protobuf buffer, which, I mean, not buffer, but protobuf AST, which comes from this function. And we must return an inference op, basically in tract. So that's a tract object. Let's not talk too much about this. This TopK operator, so we will have struct. So we need to match whatever is present in the ONNX specification, because we must represent all we need to do the computation later. So we'll define a struct called TopK. I'm going to use this syntax to match the TopK file name without underscore, so no underscore, so no capitalization. Let's try to be consistent for once. Array compress. So this is going to be an inference operator. So there are a few things that it has to implement. And so we need to parse some attributes. So we have the largest, which is a Boolean, and we have the sorted that we will just gonna ignore. We will consider it that it's true all the time. And there is the axis. So so the axis job is already done in the other operator that I cut and paste. So let's do this. Oops, wrong. Yeah. Let axis equals this. And so we are going to have an axis. I'm using a E64 because it can be negative. And actually the default is a negative value. -1 because we assume that by default we're going to sort from the right. And we also need the other option is smallest, no, largest, defaulting to 1. That's I mean, it's very bad to default to 1. Everything should default to 0. Anyway, I don't have the choice here. I must do whatever the framework is doing. So largest at this stage, I want it to be Boolean. So node get at opt largest. Okay, and the purpose of this is to build the TopK structure with axis and largest. All right. We need to fix a bit of syntax, and we need to specify the default. So here, the default for axis is -1 as x is A64. Here we go. And for largest, so largest default is 1. So here I'm reading is 64, and as I want it to be a Boolean, I'm going to test if it's equal to 1. Unwrap. Oh, here we go. And what's wrong now? What's wrong is, yeah, we have a bunch of things to implement for this to be an acceptable operator. So next we need to implement op for TopK. So op is TopK like that. So op is it's mostly a metadata trait. I mean, there are 4 traits that we will have to implement, but for now we will start simple with op. So op is metadata like the name of the operator, TopK, and also this, which say that for now we are not going to implement one of the 4 traits, which is a typed op trait. We will skip that one for now. We will implement instead the eval op trait, which is the one which evaluates the operator. And we will have to implement the inference rule op, which is the one that allows tract to perform shape inference when loading the graph and preparing it for the next stage. So inference rules for TopK, and here it's TopK. Here we go. So now this guy should be happy. This guy is happy too, and we just need to implement this trait. So in eval, as I was saying, the main point is evaluating the operator. We'll have a bit of a problem, I think. No, maybe not. No, we'll see. So just doing this so that we have the protocols. Is stateless, I think we should manage with is stateless being true. I have a bit of a doubt, but I think it should be okay. So that's for eval, and for inference rules op, this one will be tricky, and that one will be tricky too. So for inference rules op, we will have rules. So that way we get this ugly prototype, and we need some function that enable jumping from one trait to the other. So this function implements method. I mean, this macro implements method that I mean, it's the asOp method. So from our inference rules op, we can actually get access to the op. to call the method on the hop, because in Rust you don't have trait to trait typecast. You can actually I mean, you need to go through the struct to go back to another trait. So these macro are just implementing functions that return self, but they're implemented at the struct operator, and so the compiler has everything it needs in terms of finding the right virtual table, and so it can actually implement. I mean, it's a manual way to implement a trait to trait cast. Okay, let's do this. So first thing is here this function is called just after we load the protobuf buffer, and its purpose is to figure out all the shapes of the network, because it's not mandatory to specify the shapes of the tensor that are exchanged inside the model. So that's what we are going to do now. So first of all, we will check input arity. So we're just checking how many inputs do we have compared to how many we expect. And same for outputs. And that's a weird one. We have two outputs, which is pretty rare actually. And as we have two outputs, there is one more thing we need to do. I think we have a number of output functions here that we must use to specify that we will have two outputs. So there is a default implementation because most of the operators will have one output. So yeah, so I mean, we have a couple of operators that, when I say couple, it's really not a big number. Yeah, so we have like 1, 2, 3, 4, 5, 6, 7, 8, and I'm not even sure why we have this one. So it's 8 out of, I mean, you've seen the list of ONNX operators. So the default implementation with returning 1 makes sense. Okay, next we need to check. Next we can check for each of these two inputs. So we have X and K. We are going to check whatever we can, which is not a lot. So what constitutes a type in tract is the element type of a tensor. So what each value, each number in the tensor will be. Is it a float? Is it a E64? Is it actually a float 32 or float 16 or float 64? The shape of the tensor, so the number of dimensions, which are also called rank, and the dimension of each of these axes. And that's it. So here we are in the inference frameworks, and the inference framework use kind of declarative syntax that allow us to specify rules between the various inputs and the various outputs of the operator, and then the framework will be responsible for applying this rule and trying to figure out every bit of types that the model works with. So what can we say first about the types? What we can say, and it's very explicit here, is that X and values have the same types. So that's, the syntax is a bit of brainfuck, but it has been working for a couple of years, and I'm not really happy with it because it's super difficult to work with. But on the other hand, I don't want to do it again. and I don't want to spend a couple of days rewriting all of the rules for the I don't know 100 of operator that we have for ONNX, because there is TensorFlow too, which has the same kind of stuff. Okay, so that's our first fact. T here, T there. So next we have we are going to do all the typing. K is of int64. That's easy. So K is our second input, equals 1.datum type, and so it's of e64. Then we have the second output, and it's the same. It's e64. Okay, we have the types. So after the types, we can move on to the ranks. So some of them are easy, some of them are harder, but what we've seen from before is that let's have a look here. So there is one thing which I'm not sure. Why is there a R here? Yeah, that's just this is just wrong, I think. I think there is a mistake here because we're going from A1 to AN, so why not A0? And R is supposed to be the rank of input, so this is a super weird way to spell it. It should be, I don't know, A1 to AR, maybe not A1 to AN. So I think there is a mistake here. What the operator does actually is it will take the full tensor. Yeah, I mean, that is super weird. It will take the full tensor, and on the given axis, it will just select the top lines. So it shouldn't change the rank. So the rank of input and the rank of output should be the same. It's weird. It's a very weird thing. Let's look at the example here. We have an input which is, we have one, we have rank 2, it's matrix, and the output is values ref. Here it's of rank 2, so yeah, rank of input equals rank of output. Doesn't, I mean, the specification doesn't make real sense here, so let's do this. Rank. Outputs 0.rank, and the first, the indices, wow, it's super weird. It's a super weird operator. So the indices will be will have the same rank too. It's weird because it will always repeat the same thing over and over and over. So it's super weird. Oops, no, I need a second line for this. Here we go. And so we just have one more rank to specify. It's the rank of input 1. And from the spec, it says that K is a vector, so a single vector. So why make it a vector if it's a single value? I mean, it doesn't make any sense either. but that's how it is. So a 1D tensor. So tensor of rank 1. Okay, next. So we've done ranks, we've done datum types, but now we need for each of the dimensions, we need to give. I mean, for each of the axes, we need to give the dimension. So solver dot equals inputs. So easy one is k because it's a 1D vector of 1. So shape 0 is 1. Okie doke. 2D maybe. Yes. And so now we can move on to the other dimensions, and so the first, I mean, the non-k dimension will be identical between input 0, output 1, and then we have the k. So the k dimension, it's not the k dimension, it's the axis dimension. So k can also be negative, and we need to know if k is negative, to know which is the axis, we need to know the number of axes, so the rank of the input. So we can only compute, I mean, it's a bit of a simplification, but we can only compute, make the relation between the shapes if we know the rank of the input. So it's a bit of simplification, but because if k is, I mean, if the rank is, sorry, if axis is positive, then we can still say stuff like, okay, I don't know how many axes this tensor will have, but it has as many because it contains k, and all of them to the left will be identical, and the one to the right, but I don't know how many they are, will be identical too, and I have k in the middle. But I will not go there. I will consider that we know axis. We know the rank of the input, because usually we know the rank. So it's not a big, it's not super, I mean, it's not a strong requirement to make. So I'm calling the solver S here, the subsolver. And so this closure will only be called if the solver has been able to determine the rank of input 0, which it should have been able to do, because between the rank of the input 0 and the rank of any of the outputs, it should be able to figure it out. Usually it's just known from the rank of the first input. So in that case, we will know. All right. So we know rank, but rank can be negative. No, sorry, we know axis because it's an attribute, but it can be negative. So let's compute the actual rank fixed as a positive. So I'm doing if rank is positive or null, I'm using rank. And if not, I'm doing crazy things. So it's completely wrong. So if self.axis is positive, in that case, the axis I will work on is axis. If axis is non-positive, then, which means negative, then I'm going to use self.axis plus rank. And I'm casting this as usize. So now axis is a unsigned number, which I can use in a table, I mean to index table. And as I know the over rank, I can now iterate over all of the dimension of my inputs. So for EX in 0.rank, so I can do S dot equals, so I have two cases. If ix index is not axis, then the rank of input and both outputs are the same. Not the rank, the shape. Yeah, so let's cut and paste this. So my solver is called S in the closure, just to gain a bit of a place, and shape AX. Oops, nope, maybe there, yes. Yes, and yes. Expected E64 font usize, because here rank is not a usize. Okay, now it works. And if I'm on axis, this is where K comes into play. And so we may have a problem, because maybe we know K and maybe we don't know K. So we'll assume that we don't know K, I think, for now. And this is going to be complicated. This is going to be complicated because I need to introduce a symbol. So, or maybe not. I mean, we'll do it the easy way. We'll assume that, yeah, we'll assume that K is known. So given, so I can, I mean, there I was checking for input 0.rank, but I can do the same and check if I know input 1 dot value. So value is value will be the one and only value in the 1D vector. So bit of a closure, S and K, because that's K. In that case, I can say that outputs 0 shape IX is K. Outputs 0 dot shape X is K to D. And same for the first input outputs. What's wrong now? Yes, I need to end the closure with a nice OK. Yeah, I was expecting something like that to happen. So K is a tensor. Yeah, so I mean I can access directly its first value like that in the inference framework, and so yeah, that should do it. At least if K is known, which it is in the example that we've been given. So at least there we should be fine. Well, let's have a look. So for looking at what the inference part does, then we need to run the test in tract command line, because the test runner just runs always the same thing. It doesn't give us control about what we are trying to do. And here I want to see the type inference. So I know by heart now, after a couple of years of working with this, where to find my test data node and top node test TopK. Yes, that's the one. And so if I do this, it will crash. Will it crash? What will it do? Yeah, it will crash because it should crash on the eval function here, because it will, by default, it will try to eval the test. Because the command line understands that it recognizes it as an ONNX test, and so as I'm not specifying a subcommand, it will try to run well, and it fails even before getting there. All right, that's fine. What I want to see, and now I'm going to ask it to stop at analyze time and to show me the result. So that's not too bad. Or is it? I was expecting to see the value for k. Yeah, I know what happens. So here we are in the case where our test contains the output size in the ONNX file. Because in ONNX, most of the time the input size and output size will be specified inside the ONNX protobuf file. So here these threes, this one and that one, are actually present in the file. So the analysis framework doesn't have anything to analyze. What I'm going to do is I'm going to tell it to ignore the output shapes because it's not fun. And here we go. So now it doesn't know the value for k. So we get question marks for the dimension, for a second dimension of our outputs, which is fine. And the reason why we don't know k is because by default the testing framework assumes that all of the it doesn't know what is an input and what is a constant. So in this case, it considers that everything was an actual input. So k is a variable. But another way to look at the test is to say that actually k is a constant. So if I'm doing this, you can see that k is gone because by default we don't display constants. But now k is 3, and so we can again find the size of the outputs. So this is not ideal. I mean, the big question is, I don't know how people are going to use TopK. Are they going to use it with known k value, or are they going to use it with variable k values? If I assume that k is a constant, then it's super simple. And maybe we should start by doing it like that, actually, and see what people say. I mean, I have a bug report on that, so that's an NF. This is used as sparse activation function in some architectures. Sparse activation function in some architecture. Okay. So architecture is to be understood as a network architecture, not hardware architecture. It's not about Intel or ARM. It's about convolutional or recurring or whatever, or transformers, stuff like that. People are nothing to do with our model. we can actually try to figure it out with the hints. Sparsely activated network. That's, I think we sparse activation function in some architecture. Yeah. So it might be something like that. Boom, boom, boom. So is k a constant or is k something that varies? I'm not sure. Null keeps the indices of k activation with the largest absolute value on 0. Where k. Okay. I'm tempted to think that k is fixed in advance. And if k is fixed in advance, then it's super easy to do. So we'll make this assumption and we'll take it from there. It's a good. Is there any place where k is the actual value for k is given? Blah 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 blah. Just tell me k is equals 3 or something like that, and I will be happy. So we have Q, dataset, we have M, we have some convolution factors. Okay. Well, it's not super clear. I mean, it's not super clear because I don't want to read the paper because it's going to be super boring. So I'm going to assume that k is constant. Okay. And so now I will, now that we have inference, we can actually remove pass analyze and we will hit, now we should hit this to do statement. Error stage type. Values TopK cannot be typed. Yeah, no, it's even something different. It's this one, which shouldn't be a problem. So I'm gonna keep the pass analyze for now because assuming that we can, if we don't put pass analyze, then we assume that the network can be typed. So each function in the network is a type hop. So as I just want to run the network, like that. Okay, now we are hitting the to do here. So let's try to do an implementation for this function. So first we are going to assume that okay, that was super fast. So I'm going to, yep. Here we go. Here we go. So there, eval. So first we need to so we are sorting the planes. We are sorting them according to the value on axis, I guess. TopK TopK sorted implementation. So here the axis is 1, so that's the inner axis. So the inner axis is the horizontal one. And oh, no, right, it's a bit different. We are actually I mean, are we mixing up the various because this input is a bit misleading. I mean, so the three vectors are sorted the same way because they're increasing the same way. I mean, the pattern is the same. Do we have a bit more info? No, they use the same pattern. So they should have put some random in there. Top sorting implementation. I'm not sure what that is. It's something which is probably in the ONNX framework. So for all useful purposes, I don't know. I'm not sure how it works. Should retrieve TopK layer. So I guess I need to consider every vector on this axis and sort the values in the axis. So yeah, okay. The value of the TopK element along the specified axis. Okay, okay. All right. So first of all, what we need to do is we need to figure out the shape of the output again. So shape of the output, of the two outputs actually. So it's the shape of the input, except we are putting K on axis. So before I'm doing that, input and K equals inputs. So this is a macro that just tries to it checks the size of inputs and returns the two elements as the two elements over two size tuple. Once I have this, so K is a tensor, so I need to make it a value. So let K equals so K is tensor. So so I'm gonna use cast to scalar E64. So that's this will at the same time try to cast the content to E64. Then on top of that, return it as a tensor. So E64 as a tensor, as a scalar, as a single value, as a E64. So this is a A64, and I'm going to cast it as usize because it's about doing indexing and stuff. What's wrong exactly here? I don't need this star. Okay. So this so shape is a field, so that will give me and its input. So that's okay. That's a vector of usize, which I can use to build the shape of the output. So output shape of so the axis. Yeah, the axis. The axis. We need to do this again. So if self-axis is positive, then we take self-axis. Else, if it's negative, we must add input dot rank. No. Yeah, this one will be so this guy can be negative. So I'm going to go through E64. Here we go. And output shape of axis equals K. Right? And finally, I'm going to build, so I'm going to assume first that all of the inputs are floats, because why not? And we'll generalize over the types later on. So my first output values will be a tensor of f32 and I will initialize it at 0 and of shape output shape. And we have output indices. So this is wrong. 0 comes here. Here we go. 0 output shapes. And I'm going to return a tvec of output values and output indices. And this is A64. So if I run, I should have an error which says that something is 0 and should not be 0, that kind of stuff. Let's make it compile. We have error case here. What's wrong there? Shape is private. Okay. So what's wrong? Expected. Really? Yes. Tensor and t-values. Into t-value. Into t-value. Okay. Cannot assign to output shape. So here what I want is I want it as a vector or a t-vector. Okie doke. And what's wrong here? I need input to be immutable. All right, compiling. So let's see. So we should have, I mean, these two things will be at 0, and we should have an error saying that 0 is different from what we are expecting. Nope. TopK cannot be typed. I thought I had told it to not try to type it by stopping at the analysis stage, but now, yeah, just the wrong command. And now it's happy. That's highly suspect. So basically it means that my test is not testing. I think it's because by adding more attributes here, I have confused the command line, which no longer consider our network a test. So I'm going to assert manually the outputs. If I can find assert output bundle, assert output. So I have two outputs to assert, so it may be tricky. So I'm going to shift and go back to the ONNX test suite. And I have not this one. Dash ignored. Okay. So I should have the error 0 equals something non-zero. Yeah. We have our zeros, and this is the expected output. So now, how do we do that? So we need to consider in turn each vector on the k-axis and sort it and write these values into output values and the argmax indices into output indices. So one way to do this is to iterate over all of the we can consider the input shape. We cancel the axis, the main axis dimension by setting it to a 1, and we iterate over the remaining of the shape, meaning that we are going to go through all of the vectors. What we are going to do for this is tract has some very limited capabilities to address tensor element by element or dimension by dimension. What I'm using for this is this great ND array, and so what I would like to do is iterate over a shape ignoring the axis shape. And once again, I think I'm going to have to do it by hand. I don't think there is something that will match. I'm saying again because the other operator I did the other time was trilu, and I had to do something. I had to do the exact same thing, and I looked into ways to iterate as I wanted to iterate, and couldn't find anything built in, so I had to go through indices in the end. So I think it's actually the same problem here, but it's okay. So let's declare iterating shape. So iterating shape is the same shape as the input or the output. Dot clone, except on the axis we will put a 1. And so that way I can call one function of ND array, which is called indices, and which will give me an iterator that will iterate over every available coordinate in this shape. Let's see what it looks like. Chords dot. I had the same issue with the operator I did 2 weeks ago. So it's 2 chords dot. Because the output is confusing if we don't do anything about it. Is it slice? It seems pretty happy. Except here, yeah, just need this. Okay, no, it's not happy. Same problem. Really the same problem as last time. There is something to get a slice. Nope. As so it's a bit of deja vu, but that's me. But I can do as a review. Okay. As a review. Oh, now it's working. Thank you, completion. Okay, so we should see, here in our example, the axis was 2, so we are iterating over the outer axis, and so we should see 0, 0, run 0 to 0. Suspense. Zero, zero, run 0 to 0. Okay, just as predicted. So now we have this, and we need to consider all of the elements on this second axis, which is axis, and we need to consider them, extract them as a vector maybe, and sort them. So to do this, what we can do is we can take a view on input. We will make it mutable. So a view is an ND-array construct. Okay, so we need to, so input view equals, no, I'm going to do it there. So view, so I'm going to take a view of my input tensor. So my input tensor is input, and I can tract in order to interface with ND-array, can give us a view, an ND-array view of its data. And the nice thing about the view is I can change, I can, this is why I made it mutable. I don't plan on mutating the content, the actual value, but I will twist the view itself so that I'm going to select the part that I want to look at. So for every axis in cohorts, I'm going to call this x in cohorts.iter.enumerate. I'm going to do view dot index axis, and so axis is ix and index is x. A bit confusing again. And I think I need to do it in place. Yes. So axis, because there are many things called axis, and that's the one we want is the one from ND-array. That's good. Iter, I can't iter. Come on. Slice. I should be able to iterate. What can I do on this? So cohorts as a review. Yeah, that's back to where we were 5 minutes before. Iter, yes. Enumerate. And x need to be starred. And so now I'm going to show you the cohorts, and we're going to look at what remains in the view. Here we go. Here we go, and it doesn't work. Len is 1, but the index is 1. Yes, because I forgot a detail, is I don't want to do this on axis. So if ix equals self.axis, which is not self.axis, it's axis, because self.axis can be negative, and we don't want this. Oops. Bit of BI snafu here. There we go. There we go, and suspense. So we have 0 for 8, 0 for 8, 0 for 8. So it's not exactly what we want. Something is wrong. Let's have a look at input to review F32. first. Oh yes, of course, if x is not axis, it should be better like that. So what do we have now? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's good. So we have extracted the value that we want to, I mean, ideally select, but we will sort it. We decided that we were going to sort it. So now I can use. So now I need to view. So I can use an iterator on view, which will give me the 4 value that we want. And actually, I mean, if we want to do the select bit, problem with select bit is it's not tested, but it's not covered by the test. Anyway, let's forget about this for now. So we can have an iterator on these values. We can sort the iterator and we can take the first k element. So what if I'm doing view.iter.sorted, yes, dot take k. Sure, the problem is, of course, F32 is not sortable. That's because the road designer a bit paranoid to my test about this. So first I'm doing a clone so that we unreference F32. That's right. So before it was ampersand F32, now it's F32. And so there are several tricks to handle this. And I think we have, I don't know, I think now we have on F32 in Rust, we have a function that actually implement the, because there is an order defined by the specification, but Rust didn't, I mean, the Rust designer didn't want it to be the default. I think that there is now a way to use, yes, total CMP. And it's available since 1.62. And I think tract is, if I remember correctly, I think it's 1.64 because of, yeah. Let's check this. So now tract 65. Okay, so it's fine. We can use this function, and it will take two reference to F64. So it should just work like that actually. Total CMP. Total CMP. Okay, let's have a look. Take K, I mean, I need to do something with this because it's an iterator. Collect vec. So collect vec comes from also comes from iter tools. So here we have ND array, and then we are switching into iter tools. So it's a lot of framework. Okay, so that's our input. That's our first line, and this is 0 and 2. So there was this question about by default we want the largest. So if we want the largest, then I assume it's largest first. So we're going 10, 9, 8. I mean 11, 10, 9. So clone dot map. So I'm going just to change the sign. If we are in largest mode, I should do the trick. X minus X. So if self dot largest doing minus x else x. Okay, I'm sorting them, and now, no, don't like it. Okay, not a big fan because I'm going to do this a lot of times. Okay, we decided that the function was not performance critical, so let's just do it like that. So 321 765 11 10 9. That's good. That's what we want. But we also need the argmax, shows the position of the value that we have kept. So if I'm doing this, then I'm gonna have to fix that. So we have A and B, and A is now a pair of A is now a pair with index and F32 value. So we need to do B.1 or A.1 F32 of B.1. What's wrong? Expected one argument from true. So that's, I guess this is sorted by what? Take K. Yeah, so here we have position and value. And so if we are in largest mode, we switch again the sign like that. Expected one argument from 2. Okay, I'm gonna run 0 here because it tends to be more readable in the terminal, except our terminal is super constrained on this screen, because I want you to be able to watch this on phone, as crazy as it sounds. Yes, yeah, what, I mean, that's, what? Okay, all right, so that's minus val, and this is val. So now we should have pairs, and so the first element of the pair is the index in the vector, the position. So we can use that to fill the second output. And so now, instead of printing this, I can get rid of this. Good. I'm going to use a for loop. And I will have argmax and max in this, and I will need also one more index. And should I take it as an index? Maybe you can do better. I mean, so now instead of printing it, I'm going to write it into output values and output indices. So where am I writing this? I'm writing this in chords dot chord of axis equals k, no, equals index. It's better. Dot enumerate once again. So chords of axis, try to need it mutable. Let's make it mutable. Now it's mutable. Equals axis, and in output values of axis, I'm putting the max, and in output values, in output indices of axis, I'm putting the argmax. And I think we are done. It's not axis, it's chords. 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 Cannot index, so output values is a tensor. Yeah, so I will need a mutable view to be able to change it. So once again, in tract, I cannot, I don't want to repeat all the functionality which is in ND array. So I'm using ND array. So I'm exporting tract data as ND array view, input value, output value, except this is a mutable view to array view mut to array view mut of F32. Here we go, and I'm doing the same for indices, except indices will require to be of type E64. So now output value views, view, output indices view. This guy user size, I need it to be E64. Chords, borrow of mood value, value borrowed here after move. Where is it moved? Exactly, let's try to get a better formatting for the error message. That's what VI provides me. Cannot borrow as mutable. Okay. Mute, mute, bloom, bloom, bloom. Chords. Okay, I cannot use chord like that. It's fine. I'm going to let chords equals chords. I'm going to do this because I'm repeatedly looking into chords. No, it's okay, I guess. Yeah, I can do it right away. Let chords equals chords dot. I mean, it's super weird that I cannot access this as a slice. I think I'm missing something in the ND array API actually, but okay, not a question for today. And that I can access a slice, so I'm gonna unwrap because I don't think this can fail given how I got the chord from there. So now here I can just look into my chords, which are a nice slice. In chords dot iter dot enumerate. Chords, it will have to be mutable. Chords iter. Chord as a review, create a temporary value to this. Unwrap. Okay, yeah, I will need to own it and be able to change it. So we'll make it a tvec of usize. tvec of usize, just like that. Okie doke. And now here I can, like this maybe. Yes. Whew. Yay, working. I mean, compiling, and I guess it's working. We should see okay. Ta-da! Okay, it's working. So this one is working. I also prepare it for largest and smallest. So I guess the other smallest test will run, because our tests were in TopK. We had TopK. We had TopK with negative axis. I think I'm prepared for that. I've done it. And we have TopK smallest, and I've done that too. So I think we should have the 3 plain tests should work, and they're working. And no, because there is exact here. Okay, our 3 tests are passing. That's good. Bit of cleanup. Print line here. All right. SRC ops array TopK diff. So yep, git compress. I remove 2 blank lines. Doesn't hurt. Commit. Introducing TopK. It's not finished. We've only done the first part, because now we need to go to push it a bit further. So we've done the ONNX level operator, and we need to decide how we want tract to implement the feature, because I already explained that last week, but I'm going to do it again quickly, and I can play with my second cam now. To my coding screen. Here we go. So first of all, we need to decide what feature we want in tract core, because for now we really try to mimic the ONNX specification, and so we we just used the inputs as the input that were in the ONNX file as inputs and the attribute as a field on our structure. But we made a strong hypothesis, which is that k, the number of elements to return, would be a constant because basically because it's easier and because I don't think, and it was confirmed by Tom, who has asked for this feature to be implemented, that most network that are using this operator will use it with a fixed value for k. So I'm just going to make the same hypothesis, and one day somebody will come to me and say, hey, I don't understand, I have this network that doesn't work, and it will be because of this. And this day, if I'm still working on tract, I'm gonna fix it. But not tonight, not today. If k is fixed, that means that in tract core, we are going to make it not an input, but a field of the operator. So in the serialized form, we will store k as an explicit value, and that's what we are going to use. So core. So it will look a bit redundant, but actually we will move a lot of, it's mostly about moving code to the right place and splitting stuff. So core, again, we're going to do a TopK operator in array, trying to mimic as much as I can the structure in ONNX. So in core src ops array mode, TopK comes here. I think I might have gotten it wrong on the other one, which is not super important, but I'm going to check TopK. Yes, I put it in the wrong place. Okay, it's really cosmetic. So in tract core now, I'm going to move or to copy the bits that I want. So src ops array TopK from ONNX. So what do I need? I will need axis, I will need largest as a boolean, and I will add k. But for now, I'm going to cut this. And I will need a couple of inputs of includes, which I'm going to steal from another file like Trilu, which we did just last week actually. Here we go. And so here I'm going to make a few changes. I don't want axis. I don't want to deal with negative axis inside tract core. I don't mind it. I mean, I mind it, but I have no choice in the high level function because I must implement what is in ONNX and what is in TensorFlow. But in Tractor, I do whatever I want, and I hate negative indexing. So axis has to be usize. Largest, I will keep the boolean like that, no reason to change, and I can add k as a usize. Because now k, and now I can decide that I will only support the case where k is a known quantity. What else do we need? So this TopK will have to be an operator, so I'm going to steal this bit and put it there. But now it is going to be a typed operator. So I talked before about the 4 traits that we need to implement for an operator. And these 4 traits are op, eval op, inference op, and this is a variation on inference op, And the type top. So type top is actually the now what it means is we are going to not implement the inference framework, but instead implement the typed up trait, and so our op this time will be a typed op, and so it will have functions to be cast to a typed op. And on top of that, so I actually need to provide the implementation. So I'm going to implement type top for TopK. So type top, the main function is called output facts. Didn't work. Output facts, which will set us to do. And so this function, given the facts which are type and shapes of the input, is responsible for building the shapes and type of the outputs. And the only other thing we need is a way to come back to the op trait from typed op. And I think, I mean, something is wrong because the compiler doesn't, I mean, Rust analyzer doesn't seem to work in this file. So maybe there is something stupid like mod. No, that's fine. So what's wrong? Let's go to core and have cargo check. Okay. Right, so maybe it stops before because it wants the struct to be public. Not a problem for me. And maybe now I will get more feedback from Rust Analyzer. Not super obvious. So it's complaining because it doesn't have eval op, which is fine because we already did it once. We can just copy pasta and adjust. So let's do this. src ops array TopK. So I'm stealing. I'm actually, I mean, it's gonna look a bit dirty because I'm actually copy and pasting, but we will remove it in a second. In the second time, we will remove it from the ONNX level struct. So it's not too bad. Rust Analyzer is still not working. Come on, analyze. Maybe if I'm going into... Nope. All right, so we're going to do it the old school way. Okie doke, so we have plenty to do. I won't, not gonna use a watch because the screen is too small. So first we need to include, this is going to be cumbersome. What's wrong with analyzer? src ops array TopK. So here it's working. Oh, now it's working there too. We have types popping there. Okay. Working? Not working? Let's say it's working. Let's say it's working. So we should have some errors. Nope. So line 41 here. It's a no axis. Okay. So it's only the error. It looks like it's only the error reporting that is broken. It's weird. Line 28. What's wrong here? So here now axis is positive, so I no longer need to do this. I can just use self.axis everywhere. Axis. Okay. Let's fix this one. That one. We'll fix this one. And that one. Okay. And that's it. Yeah. What's next? As a review, line 37. So method not found. Yes, so I need to add a trait. I think if I do this, yeah, up. And sorted by comes from iter tools. So sorted by. Yeah, that's good. Okay, it's compiling now. So we need to implement output facts. So in our case now, the only thing we need to do is we need to pick the shape and types from input, change the axis by k, and that is our first shape. And the second one for second output is the same except with a different type because it's the indices. So let's fact values equals inputs 0 dot that's already the fact. So input 0 dot clone, because I'm gonna change it. Or actually what I'm going to do is I'm going to use the without value because I don't want to keep the value. I mean, some facts are constant, and if they're constant, then I also get the value. But here I just want to return the shape and element type. So without value, just strip. If it's there in the fact, it will strip the constant value from it. I will do the same for fact indices. I will change fact values dot shape dot fact values dot shape dot. I think I have a set method. Yes. And so I'm changing self axis and I'm putting self dot k. Same for indices. And ultimately, I need to change in indices. I need to change the type, put datum type, and I need to make it E64 datum type. And that's these are output facts. tvec of fact values and fact indices, and now I get errors. Go figure. All right. Yeah, well, I get some errors. Not all of them. So k is usize, and I need actually a tdim. So tdim is a super type of usize. I mean, it's not super type per se, but tdim or expression, because we can have dimension with symbol in them. But in our case, we assume that k was a well-known quantity. So I'm just going to do not this, but to dim. All right, and the same here. And then what? Then what? No, yeah, then it's fine. Okay, so now we have our operator in core that is probably working. And so now we are going to do the cleanup in the ONNX crate to use the new operator that we've just introduced in core. So TopK. So TopK will no longer need to be a full-fledged operator. It will be something much simpler, which I called expansion. And you can see it as a macro. So the good thing is moving from a full op implementation to an expansion is usually very simple because I've kept the same method name. I mean, I've done it so many times that I wanted something to be simple. So, I mean, even simple to type and etc. I'm lazy. So in eval, I've moved to core, so I can remove eval entirely. And then I can keep the rules method as it was. And I think this should be close to the truth. Close, but not exactly right, because so I no longer need these guys because they were only used in the eval function, which is gone. Here, instead of returning a boxed operator, I need to use the expansion that will actually build a magic wrapper around my expansion, which implements the right trait from operator. It's not expansion, it's expand. And yeah, I need the wire method now. So the wire method is the method that translates. I mean, it writes. It's a substitution function for our expansion, which is a kind of macro. So this will actually translate our ONNX level operator with axis that can be negative and largest, and two inputs, one for the input and one for k, into the different specifications that we have chosen for tract core, which is axis has to be usize, largest is the same, and instead of an input, k comes from a field. So there is one bit I can salvage. It's this one, the one that makes axis positive. So I need the rank. So the rank will be given to me by inspecting my inputs. So let input fact equals. So I have two inputs. So I'm going to use my args2 macro. Will it work? Will it work? No, it won't work. So I have an input. So my main input is input 0 dot just input 0 actually. My k input is inputs 1, and I can only proceed, and this is where it will break if we have a dynamic k. I can only proceed if k is a known constant quantity. So if let some k equals so k is tensor at this stage, but I'm going to do k dot cast to scalar as e64. So if so it's wrong because K is not a tensor at this point. K is an outlet. So an outlet is it's an outlet ID actually. So it's the identifier of a wire in our network. So if our neural net is let's find an example. Yeah, I mean, you don't have to worry about what the example is about, but so I'm coming back to the code. So outlet ID here is identifies a wire in the model, and I can introspect the model to know what is the fact. So combination of element type and dimensions for these two wires, for these two inputs to our operator. So input fact will be model.outlet facts of input, and same way that k fact will be same thing for k. Here we go. So now k is a fact. So a fact is element, shape, and optionally a constant, except the constant is very much not optional in our case, because we decided that we were not going to do top k if k was not a constant. So no field const, yeah, it's k fact. K is the I'm going to change this because usually I do it like that. It's a bit easier actually, because this outlet I will never use them again, I think. Not completely true. So inputs are now the facts. So k.const, hopefully it will be something. So I need to know the rank of the input. That one cannot fail. I mean, we always know the rank in tract core. So rank will be input.rank. So now I can use this to compute the actual axis number. if I don't know k, then the function will fail or bail. So here if we get there, we will only return an error, and that's the error that somebody will cut and paste someday and put on GitHub because they have a network that doesn't work because suddenly somebody is using TopK with dynamic value for k. So let's try to make it clear. Tract only supports TopK with a constant k. Okay, so one day I will have to fix this, but not tonight. So now we've done. We know the axis. So let's try to remember to build the tract operator. We need axis. We need which we have. We need the largest boolean, which we have, and we need k, which we have. So here we can build and plug into the typed model. We can put our typed operator. So let's do this. We're going to call model.wire node. So this function does everything that we need. So it creates a node, it puts the operator in the node, and we will specify what are the inputs. So the network can be built step by step, top to bottom. So wire node, we will keep the same node, so the first argument is the name of the node we are going to create. So I'm going to keep the same name, which is given to me as prefix. So it's prefix because sometimes you need several nodes from tract core to implement one node from ONNX. So in that case, you would use prefix dot part 1 of the operator, prefix dot part 2, etc., etc. But in our case, we have an exact mapping. We have one node in ONNX and it will be one node in tract core, so we can just use the prefix right away. Then second argument, as you can see, is the operator. So that's the tract core operator, tract core ops array. We called it TopK, and we have the axis. We have k, and we have the largest is self.largest. And finally, we need to specify the inputs for the new operator. So previously we had two inputs, the actual input and the one providing k, but in tract core we only have one input because k has become an attribute. So here I can just use input 0. And that's it. So at this stage, I have successfully translated the ONNX operator into a tract operator, and the function just need to return the wire or wire that we have created. And this is exactly what the wire not function returns. So we have nothing more to do actually, except fixing a couple of little things. So cannot find the TopK in tract core, really. Array mode. TopK is here. TopK there. Tract core ops array. Tract core src ops array mode. What is happening? Something weird, definitely. Moving to ONNX. And show a couple of typing errors. Okay. In the reverse analyzer is completely weird today. Anyway, so axis expected E64 find U size self axis plus rank. So self axis is E64. Self axis is E64. Rank is U size. So rank as E64. And okay. And expected U size found reference. So K here is a tensor, so I still have to extract the value from the tensor. So let K is equals K dot. So K is a vector, a 1D vector. So I can access its first value. So I will make it a slice of E64. And I'm picking the first element. And before doing that, I will cast it as E64 because in case somebody uses, I mean, it's supposed to be E64. We checked it was I64 here actually, so I don't need the cast because we enforce the type already. So this should be safe. Question mark because it can fail. And so we are back to this weird error. Nope. I shouldn't look at anything happening on the left. And so I can cast these as U size. And okay. Maybe this is what is confusing. No, I don't think so. I think it's just weird. Ops array TopK. Bloop bloop bloop. So I need all of these to be public. Okay, and so the good thing is I have tests for these because if I'm coming back to here, I had ignored. So if now I'm trying to run all the test TopK tests, there are 9 of them. We had 3 of them working, and we should have 3 more now. So the 3, I mean, we have 3 tests coming from. Okay, nothing. We have 3 tests coming from the ONNX test spec, and we managed to break all of them. Yes, it makes sense, at least for these ones. So the plane were working and we broke them. Yeah, we broke everything. So the reason why we broke everything is we made an assumption which is K is a constant. And if we want the framework to know about this, we need to change. So here we have this for supporting the ONNX test suite. We have this huge list of operator and tests which are supposed to work. And for some of them, TopK, so TopK are not there because they're not working. That's expected, except now they're working. So I'm going to add them. Shouldn't have to do that actually. I made a mistake before. It's okay. We'll do it like that. TopK. And I'm going to specify, just like here, that only the input called X, and I don't remember, I think it was big X, not small x. Only the input that the test is calling X is actually an input. The other input are constant because the other input is K. So K will be a constant for the network. And so we should see we should see our plane and I guess the optim test for TopK working again. Yes, for some weird reason, even the NNEF seems to be passing, which is super weird. It shouldn't pass. Why is it passing? It wasn't tried. Okay, it wasn't tried. Why? Because. Oh yes, because I'm asking for the ignored. And nope, it's not passing. All right, so what's wrong now? Panicked. So let's try to find error eval during inference. So what is happening? What's wrong? Okay, let's try to go there calmly. So TopK is failing. Eager eval during inference, evaluating ad hoc, expected 2 args. Okay, so expected. So the key is this: expecting 2 args and got essentially 1. And the reason is I didn't completely fix the function in tract core. So I'm going to do it now. Array. So before we had 2 inputs, x and k, and now we just have 1 input. I'm going to use arg1. So k no longer comes from there. So I no longer need this. K comes from self. The rationalizer is still not helping. I guess there should be a couple of apparition of k, like take k. Yes, so it's self.k. Okay, so k is back in order, and so the question is, will optim pass? So optim is a bit of a misnomer, but it's optim is when we have moved the operator to tract core. So basically test that we can translate our operator to typed operator by calling the wires functions, and it tells that the resulting network is still giving the right result. So that's good. We have test TopK, plane and optim working. And the next thing is I'm going to add to check that I haven't broken more stuff. So negative axis with x, and the smallest with x should also work. Let's check that. So we should see 3 OKs. Perfect. All right. So now if I'm looking at all the test TopK, why is the NNEF test working? That's really bad. Yeah, that's incredibly bad, because I haven't implemented the NNEF support yet. So the reason, I mean, that's super weird and super bad, and I suspect that the test harness is broken actually, because, I mean, it looks like it doesn't test the NNEF serialization as it should do. So that's super strange. Unless, let's have a look. Cargo run. Yeah, I have an idea. Maybe the framework is not the culprit. So I'm going again to run our test from the command line because I want to see the network. So ONNX, now the version scheme, then it's ONNX again, and then it's backend, test, data, node, and the test I'm trying to run. So we will get an error because k is not a constant. Okay. Tract only support TopK with non-constant k. Good. So now I'm stopping the processing at the analyze step. And yeah, okay, this is what I got wrong. I thought it was big X and it's small x. And so what happened is my mistake made the framework say, okay, if big X is the actual input, then small x and small k are constant. And if this is constant and this is constant, then I can evaluate this guy. And so basically the network was folding to a constant getting the right value. And this is why it managed to serialize it to NNEF. It's because you can actually serialize a constant in NNEF. It's fine. So now we should be back to something that to something sensible. So the test that I haven't implemented yet should not work. And they don't. So the 3 NNEF tests are failing. And so what we are doing now is we are so how do we want to serialize in NNEF our operator? NNEF is a text representation for neural network. So we don't have much to define. We just need the name of the primitive we're going to use. So we already have a lot of them. So it's going to core. So NNEF is a pretty well defined subset of ONNX. So TopK is not part of NNEF. So we need to make an extension. And it's not the first time it happens. It happened already a lot of time. Core, do we have a mode here? No, it's core.rs. Yeah, it's done the other way. And so in this specific case, what we are going to do is we are going to add, it has to go before Trilu. We are going to add to register function that will translate from from the in-memory tract core form into NNEF text. So dumping, writing it as NNEF script, fragment of script, and the other way around, loading from this script to the in-memory tract core form. So TopK, and so I will need to register a couple of functions, exactly a couple of functions actually, one for loading and one for dumping. And I'm gonna take inspiration here. So this function will be called by the big list of functions that we've just seen before. I'm going to cut and paste everything and then change it in place. It will be easier like that. I would do it differently if I had a bigger screen. The dumper first. So the dumper will dump TopK operator using a function that we are going to call ser TopK. If framework, if analyzer is nice enough, yes, looks good. Observe TopK. Yeah, there is definitely something broken because it's there. I'm importing tract core ops and it should be there. So, okay. So this is the name of the primitive. So the function name I'm going to use in NNEF to represent our operator, and it's tract core TopK. The parameter of this function will be the input. So in NNEF, there is no distinction between attributes and input. So everything is an input, basically. So we have our K. By luck, we already have something called K in Trilu. So we have also Boolean, except ours is not called upper, it's called largest. And we have an axis, which is, so axis, it's of type, yeah, I made a mistake. So axis is an integer. So scalar is scalar here should be integer because in NNEF scalar is the content of a tensor, so it will be like I mean it means float, but k is the size of a tensor, it's a dimension, so it's an integer, so we should use integer instead. The types, that's because the types of tract core, which are very close to the types of ONNX and TensorFlow, are different from the types present in NNEF. In NNEF, there are just essentially three types: logical for booleans, integer for dimensions, and scalar for whatever is inside the tensors. It's still not happy about this. And so we have two outputs. So first output is values, which are scalars, and second input is indices, which are integers. All right, and so the deserializer will be deserializer TopK. Didn't work. Okay. So writing these two functions should be, I mean, all of this is really mechanical. It probably could be done with macros and CRD and stuff like that. I just never had the courage to do it. So input is our input. K is K. We need axis, which is going to be so that's a serializer. So K, no, that this is wrong. So for this is TopK. So you can see that we are not actually writing the NNEF text, we are actually populating an AST that is going to be serialized by an NNEF serializer, which is a part of the framework. So tract core TopK. So these are the input tensor. We have input and that's it. We have then the three arguments. So the three attributes, starting with K, which is an integer, and actually it's not a tensor, it's an integer. So it's not a tensor of integer, but a single integer. And so it should be integer. No, it's numeric. Yes. Of, and here I must refer to op.k. Upper, there is no upper, we have largest, which comes from op.largest. And the third argument is axis. Which comes from, which is of type numeric and comes from op.axis. Is it clean? Sure, not really, it's not happy. So yeah, because op, I mean at this stage, this function is only called if the framework was able to match TopK with the operator, with still this weird thing that analyzer is doing. So here we can be sure that it's actually TopK. Again, we have the reverse analyzer problem. So that's missing parentheses here, and it's actually there. So I guess we are good for the serializer. And so now it's just a matter of doing the same the other way around for the deserializer. This is wrong. K is not an input. K is already dealt with. Okay. Input, we take input. So K, we take K. Axis, guess what? It's axis. And these, so in the parsing, that's the opposite thing that we just did. So invocation is a bit, it's a resolved invocation that represent a bit of the AST, and the named arg_as method actually curse the type of what we are retrieving. I mean, it's a converter. So if I'm writing here TopK with largest K and axis, this will be enough for the function right there to know how they should cast K axis and largest. So once again, this really feels like I shouldn't write this by hand. A macro or some kind of automatic contraption should do it for me. But and we still have the problem with analyzer. Or is it a problem with analyzer? We have an issue in line 35. So builder.wire, so that's a deserializer. So we are, yes, we don't have two inputs, we have just one. And here we go. Suspense. All green. We are done. And the weird thing is, I had said 2 hours and a half, and it's 2 hours and 25 minutes. So I'm getting better at evaluating how much time it takes me to not only do things, but explain them here for whoever is watching. So that's basically is it for TopK. There is just a few bits, but which are done by a script, which is a very long-running one. it will actually not work, but it's okay. So the script is supposed to put in the other test suite manifests. So here we have a bunch of them. I change this one by hand, but we have to change all of these. I mean, starting with the version when TopK appeared. So we're going to check that. So TopK appeared since version 11. So the problem is version 11 in the operator set is operators. There is not, I mean, the matching of operator set versions with ONNX version is not that obvious. It's not obvious at all, really. There is a table somewhere. Yep. That's so operator set 11. We start ONNX version 1.6. And so 1.67, etc. All of this, so except this 2.1, should be able to pass these tests. And most of the time, these things works. The problem here is it only works for tests that do not require specific settings, like we had to put on our. So the it works if it works with default, but here we also need input X. So this means that we have to do it by hand. So I'm gonna cheat a bit. Oops. Thank you, DSH, for saving my life and not overwriting the file. 1.8.1, 1.9, 1.10, 10 is 10.2, 1.11, and 1.12. .o, yes, and I need to sort this file again. So for f in node something .txt echo. I do echo because I want to check the command before running it. Echo f. And the command will be sort f overwriting f. Didn't encode anything. Yes, this doesn't work. I mean, the star, it's up to the nope. What's wrong? Yeah. So I've written. Aha! That's great. Look at what I did. How stupid that was. Okay. Okay. So I'm gonna check out this. That's for the funny one. I'm starting to be a bit tired. It's time to finish this. So cautious here because I don't want to do anything more stupid. Okay. Now I'm going to grab yes, these three lines. Okay. And so we said that we had to start at node 1.6. Okay, TopK. No, it's not there. So we are near Trilu. Nope. Oh yeah, not Trilu on this one. So I mean, I will sort them again later. Nope, not that. Okay. All right. So now I can do my grep again, except I started with 1.6. So let's do this again. Yeah. Okay. All right. Writing to node 17. Nine, 10, 11, 12, 13 something. Okay, and so the sorting again. So the sorting again. So no echo. Thinking hard. Okay. Nope, failed. Okay, so you know what, guys? I'm going to do this on my own because it's gonna be boring. Yep, I'm gonna call it a night because I'm obviously starting to be very tired if I cannot do simple stuff like that anymore. It's not a good sign. So hope you enjoyed that, and maybe see you next week if I found OBS. Yep.